A very good morning, Pon Adila. Today, my group and I are going to present about solar energy to be world's largest power source. My group members consist of Wangpit E, Sangeeta Gopi, Wanzin E, and myself, Divya Priyasamy. We are from Group A.
Solar thermal technologies. The solar thermal technologies can be classified in three different ways, which are the low temperature collectors, the medium temperature collectors, and the high temperature collectors. Low temperature collectors. Low temperature collectors can be divided into two, which are the glazed solar collectors and the unglazed solar collectors. The glazed solar collectors are mainly intended for space heating. They recirculate building air via a solar air panel where it is heated before being redirected back into the building. These solar space heating systems require at least two penetrations into the building and only work when the air in the solar collector is warmer than the room temperature in the building. The vast majority of glazed collectors are used in the residential sector. For an example, the air heater which are used in houses. Unglazed solar collectors. Unglazed solar collectors are mainly used to preheat make-up ventilation air in commercial, manufacturing and academic buildings as schools and factories with a heavy ventilation load. They convert building walls or parts of the walls into unglazed, low-cost solar collectors. They are also known as the transparent solar panels or solar walls because they use a painted perforated metal solar heat absorber that also acts as the building's external wall surface. Heat transfer to the air happens on the absorber's surface through the metal absorber and behind the absorber until the heat can escape to the outside air through convection. The boundary layer of solar heated air is drawn into a nearby perforation. The hot air is then pulled into the building's ventilation system from behind the absorber's plate. This is the example of an unglazed solar collectors where the perforated absorber is like literally the wall of the building. Next up, medium temperature collectors. Medium temperature collectors are basically not a modern invention as there are few collectors and commercial installations available worldwide. At the moment, the sector is rapidly expanding, new technologies are being introduced, and actual installations based on these technologies are being installed all over the world for a variety of applications, especially for the generation of heat needed by industrial applications. Given the growing number of available products and the value of disseminating this knowledge to device designers and end users, the database of available solar collectors for medium temperature application is being developed. The data was collected from various collector manufacturers and retailers as well as technical information reported on the various collector models. The database contains the most important technological knowledge of the many current collectors with the intention of offering a comprehensive understanding of these new commercially accessible solutions. For an example, solar calculators are in use right now, even in Malaysia. As for the solar panels are greatly used in other foreign countries, for an example, USA for heat collection for electricity generation, for an example, solar cooking, solar heater, and etc. This is an example of flat plate collectors which are installed at the rooftop for solar energy collection for electricity generation. High temperature collectors. Flat plate collectors of the non-concentrating kind are commonly used when temperatures below about 95 degrees Celsius are appropriate, such as for space heating. Even when the heat transfer fluid is stagnant, flat plate collectors will not achieve temperatures well above 200 degrees Celsius due to the comparatively high heat losses through the glazing. These temperatures are inadequate for effective energy conversion. Heat engine performance improves as the temperature of the heat supply rises. Solar radiation is absorbed through mirrors or telescopes in the solar thermal energy plants to reach higher temperatures, a practice known as the concentrated solar power. High efficiencies have the realistic effect of reducing the plant's collector size and total land use per unit of power generated, lowering both the environmental impact and cost of the power plant. For an example, as for the low temperature collectors, imagine is supposed to be for one room, and the medium temperature collectors is supposed to be for one house, and this high temperature collectors for an entire residential area. These high temperature collectors are classified into 5 types, which are the concentrating solar power CSP, which we have seen before, and parabolic throw, dish engine, power tower, and compact linear Fresnel reflector. This is the disc or the mirror that I was referring to before, and this is called as the parabolic concentrate collectors. This is one of the examples of the high temperature collectors, which is set it up in a plant as in they have like a few different parabolic concentrate collectors which collects the sunlight, the heat energy, and the solar energy or the heat energy from the sun, and they generate it to supply to an residential area or a big place.
I'm Divya. I'm gonna talk about how solar energy is produced. So, how is solar energy produced? Solar energy is produced when sunlight strikes solar panel, which then turns solar power into usable electricity. This photovoltaic transformation is the way solar energy is generated. How does solar panels convert sunlight to energy? The process of creating power from sunlight starts with the biggest part of the solar installation, which is the solar panels. A typical solar panel is made from either monocrystalline or polycrystalline silicon housed in a metal panel frame with a glass casing. This is an example of polycrystalline solar panel. When sunlight strikes the thin layer of silicon on top of the solar panel, it knocks electrons off the solar atoms. Electrons are negatively charged, which means they are attached to one side of the silicon cell. This creates an electric current that is captured by the wiring in a solar panel. This is known as photovoltaic effect. Flowing electrons that have been knocked free by the sunlight are the basic of the electricity generated from solar panels. The more sun that strikes your solar panel, the more electrons will be knocked free. So it is important to consider factors like shade and local cloud cover when designing a solar energy system. Different solar panels produce electricity at different rates, depending on their efficiency and quality. Higher quality solar panels will often cost slightly more money upfront, but in the long term will save you money because they produce electricity more efficiently.
Nowadays, solar energy has become a major trend these days. This is because solar energy is renewable energy compared to coal and petroleum. There are many ways we use solar energy. For example, for heating up buildings, for heating up water, for agriculture, and electric power generation. Do you know we could heat up our buildings directly by using solar energy? For example, we could construct large south-facing windows. Why the south side? This is because sun rises from the east and sets in the west. The building which has south-facing windows could achieve maximum advantage of the sun potential energy by transmitting solar energy directly into the building. The benefits are we could save up to 60% on lighting and heating energy. Solar energy for heating can be achieved by using solar thermal collectors. We should install solar thermal collectors at high, elevated and stable area which have maximum exposure with solar energy. The collector solar radiation could warm up water or air and can be used at night and during inclement days. When the building requires heat, the collected solar energy from solar thermal collectors will transfer to conventional equipment such as fan, ducts, and air outlets. We could also heat up water by using solar panels mounted on the roof. The water in a drainback system is pushed to the collector by using circulation pump. The water will be heated as it moves outward through copper tubes in the solar panels. Once heated, the fluid exits the collector and circulates down to the drainback system. The drainback system functions as an indirect heating up the usable household water with the fluid. Once the household water is heated, it will be stored into tank and available for use. For example, for hot shower, laundry, and washing dishes. Solar energy also branches out to agriculture. For example, by using simple cabinet dryer. Cabinet dryer consists of a box insulated at the base. The inner side and cover is painted black so it could absorb more heat. It also consists of an inclined transparent sheet of glass. The tray and rack for produce are carefully designed to provide controlled exposure to solar radiation and ventilation. Solar drying, especially of fruits, improves fruit quality as the sugar concentration increases on drying. Solar electric power generation, for example, by using photovoltaic cells. What is photovoltaic cell? It functions as a convert solar energy into electricity directly. The device is made of semiconductor which absorb the photons received from the sun, creating free electrons with high energies. These high energy free electrons are induced by an electrical field to flow out of the semiconductor when electricity is needed. Photovoltaic cell is used for street light, car, and satellite panels.
Now, I want to explain about the physics theory related with solar energy. There are two types of theory related with solar energy. The first one is thermodynamic theory, and the second one is solar cell theory. Thermodynamics is basically the study of the effect of heat, work, and energy on a system. It basically explains how the thermal energy is converted to other form of energy and it is converted from other form of energy and how matter is affected by this process. Thermodynamic theory is not concerned about how and at what rate these transformations are carried out, but actually it is based on the initial and final state of a system undergoing the change. A thermodynamic system is a specific portion of metal with a definite boundary that can be real, imaginary, fixed, or deformable. It has three types of system: open, closed, and isolate. A system will undergo a thermodynamic process when there is some energetic change within the system that is associated with the change in volume, pressure, and internal energy. Solar cell theory. The theory of solar cell explains the process by which light energy in photons is converted into electric current when the photons reach a suitable semiconductor device. Photons in sunlight hit the solar panel and are absorbed by semiconducting material. Electrons are not loose from their atom as they are excited. The electrons are only allowed to move in a single direction. The solar cell will convert solar energy into a usable amount of direct current electricity. Solar cell is a solid-state electrical device that converts energy of light directly into electricity by photoelectric effect. It is also known as photovoltaic cell or photoelectric cell. Solar cell can be classified as three types. The first is monocrystalline silicon cell is produced from pure silicon. The monocrystalline silicon is pure and defect-free. The efficiency of cell will be higher. The next one is polycrystalline solar cell. Liquid silicon is used as material and polycrystalline silicon was obtained followed by solidification process. The efficiency of this type of cell is less than monocrystalline cell. The last one is amorphous silicon. It is obtained by decomposing silicon film on the substrate like glass plate. The efficiency of this cell is much lower than that of the other two cell types. The benefit of solar cell theory is we can use solar cell technology to generate thousands of hours of electricity with minimal maintenance. Besides, solar cells also provide cost-effective solutions to energy problems in places where there is no main electricity.
This is all from